Right, so now move on to the next set, and this time it's a rather well-worn Uniden Uniace 100, and again it's from our Mr. Benefactor Alan. It's a repair which will go back to him by the intermediary. It looks like it's been in a lorry or a tractor or something all its life, and it's from the first generation of these from 1981. Now, he mentioned to me in his note that he's done the capacitors. Something about the mic not being right or something, and something about the meter. So I'll tell you what, we'll take the bottom lid off as an immediate precaution. Try not to lose the silver screws. Well, I don't seem to be able to get a source of silver screws. I can get black screws, I can get self-coloured screws, but not ones with some kind of plating. Oh, there's a screw at the back, isn't there, on these? Don't know what we'd do to replace these square speakers at 16 ohms. I really don't. Just hope we don't get any failures. And I hope that's not going to be one of them. So he's changed the 4 capacitors. So that's a task. I know earlier in his life he was involved in component level computer repairs, so there we go. Good. So that's fantastic. So I think we'll power it up. Do these have PA? Yes, they do. That's a good start. Did he mention to me that it may not be wired right microphone wise? Plug it into the test gear anyway. He's also sent a York JCB867, which we don't see many of those of. You'll probably say good, but because we don't see many of those, it makes it interesting. So we're going to connect it with our crocodile clip leads. I've got the power leads for these in stock, as you know, they're readily available, but along with the Cybernet ones, which are readily available, but I don't want to draw one out from stock, you know, to just kind of use it on the bench. Obviously they're for selling, not for using. So meter's there, but I think he said it's not working. Right, see what happens on PA. Testing 1, 2, testing 1, 2, 3, 4, 5. And the answer is absolutely nothing. So perhaps he's right and it isn't the right kind of mic pin out. So what I'll do, I'll go and get a brand new one from stock. So there's no audio coming through on that. So although we don't repair mics, obviously we do for him. Right, so everything now on the brand new test mic. I've got a couple of Uniden 100s came in that batch of stuff we bought from Lancashire, so I'll be doing another one of those in the next few weeks. So this mic can then go with that set. One of those. There's 2 Uniden 100s, another tired looking Uniden 200. Right, so let's see. So PA, the mic, we've got no audio. So PA's working. So when we key up, we have no meter operation, as he says. So meter, that's okay. We know the sockets work, so we'll go to channel 20. .9 watts. Channel 40, 3.6 watts. Channel 1, what's that going to be? 4.1? It's 4. Low power. Take it back to channel 20. We're drawing 1.026. And now we'll go to low power, and it's doing 700 milliwatts, which of course it should be 400 milliwatts. Deviation on this test set, which is probably lying low, it's 3.2. So it needs to come down. Now, I only do the VCO if we have to do the VCO, because there's going to be a fee. So we don't need to touch the VCO because it transmits on channel 1 and 40, and we can see nothing's ever been touched. And our experience with Unidens is that if it's never been touched, the VCO doesn't go out. So he can save some money by not bothering with that, because it obviously works. So we're not going to do that. Frequency, and the test equipment's been on all day. So let's have a look at the frequency counter. You know what, I've not got picture in picture. 27,79091. 27,79091. So although it should be 27,79125, it's not adjustable. It's very well within the limits. I only start worrying if it's 27,79075, something like that, and it's still not out of spec until you go much worse than that. So, you know, it would have to be less than that for me to start worrying about trying to change a crystal from something. So that will remain the same. So we'll just put it in. So with that, we'll make sure the test equipment, we set it to 27,79095. So the test gear, when we do the receive, is absolutely spot on with what the radio is on. So we're not then tuning it lopsided. 79095, there we go. So we'll now go to the synod meter. We will. There we are. So I'm at 100 microvolts. I'm hoping I can unstick this meter rather than have to replace it. Fidelity Thousands have got identical meters to these, but these are, it would be daft to wreck a Fidelity 1000 type of radio. I'm talking about the greats in general. I know they aren't as good as these radios, but these are actually worth less than the greats. So you'd be more likely to chop up one of these to repair a Fidelity 1000 than the other way round. $27,79095. We've got that right. Let's see. Let's plug it into the. Still got this attenuated speaker that I did Christmas Day, because people kept moaning the noise was annoying to them. Right, well, I can't hear it at all. Is it the wrong socket? There we are. just wait for my oscilloscope to warm up. You don't need to see that at this stage. Just making sure we're not into distortion, that's all. Okay, so let's see where we are. I'll tell you what, it's doing very well. So at the moment we've got 0.55. These are never as sensitive as Banatone 5 stars, which is probably why they're better for bleed over. Wrong box. It's 0.41. And for 20, if it does it, it is 20 and only about noise really. It's not about range. It's 1.65 microvolts. So full squelch. Full squelch is it is 2 millivolts, which is far too high, and threshold wrong knob. It's far too coarse at 2.4 microvolts. So it would be chopping around scratchy corner, something chronic. Well, I'll tell you what, I need to take a break because of other commitments, and I can never do more than 40 minutes in one run. And I'm going to do the receiver first because I've just got everything on and set up for it. So, where are we? 100 microvolts on the signal generator, and you need to look at the oscilloscope. And we adjust the detector, which I think is this one. It is. I don't think it's that one. No. Right. So it did need a bit of adjustment on that, and that can make lots of differences. It can be oversensitive if that's in the wrong position, but it'll sound garbled. We're going to drop the signal generator to about 4 dB, so we're not saturating the receiver, and see whether we can bring up the receive sensitivity. Start at the front end. That was spot on. Little tiny bit there. That was spot on. Think on these sets that's the transmitter. Just prove that. Yeah. That was spot on. Bit more signal now for these IFs. IFs being intermediate frequency. That was spot on. Now that one I touched actually wasn't spot on. Right, let's see if we can get a new reading and see whether it's better or worse. Well, we know it's right now. So for 12 dB, we now have 0.47. So it is better. For 10 dB, 0.37. And for for 20, not quite the 1, it is 1.5. Now I can't set the S meter because the meter is not working, and we'll do the squelch. So I put 100 microvolts, I'll show you the attenuator. Put 100 microvolts on the signal generator, and I want to be able to, no I won't, I'll put 30, I want to squelch it out. So full squelch. These are all labelled so it makes it quite easy. Deviation, it's squelch, there we are. Right, so it's not opening where I want it. All there. All there. So let's have it at maximum sensitivity. It's now 700 microvolts. So I prefer it to be 100, but it isn't. So it isn't a hard and fast rule. It doesn't mean the set's faulty. Let's see where it is at the sensitivity end. But we'll now come out of that speaker and we'll go to the one you can hear. We'll set the threshold on the radio, signal generator back on, parked at 0.3 of a microvolt. Oh, that's no good. Just have another go at setting the squelch on the radio because that isn't good enough. Might be my big fingers. It's my fingers. It is 0.65. Right, that's that done. So I'm just we'll quickly run through the transmitter, and this time we'll be able to see what we're doing, won't we? Because I put picture in picture on. I'll switch the oscilloscope off, I'll switch the cyanide meter off. So we want to be on full power, and we'll just run through these. There's another one I want to check on receive, and that's that one. I'm just going to backtrack. Although it shouldn't have been disturbed, I'll just go back to cyanide meter for you. I don't know, it was the tiniest movement anyway, but it won't be worse, it'll be better if anything. It's just something to watch on sets that you're from a checkered history. That's actually brought us to 4.4. I'm presuming there's no core in those. but I'll double check. But for now, that's absolutely spot on the 4. So channel 40 is now 4 watts, and channel 1 is now 4 watts. It's absolutely perfectly balanced. So that's good. And our current consumption hopefully will have come down. It has, it's 871 milliamps. There you go. So low power is now 1 watt. So it's that one. It's now 400 milliwatts. Which is where it should be. So I'm just going to look at the deviation on the test set behind me. Just to see if the Marconi's lying. What? 4.5. The Marconi's lying. 4.5. How stupid is that? Transmit on 3 channels at once. Wallow. Wallow. There we go. I'll take that break and we'll check that with the Marconi test set when I get back. So what I've done, I wouldn't do this for anybody else, but I've done it for Alan, is I've actually borrowed it of one of our Fidelity Thousands. He's very kindly sent a scrap Cobra 21X FM. Looks like it's quite well water damaged, and I expect there's a recoverable meter on that, but not one. They don't fit these. But then, you know, we do use those, so I think we'll accept a meter for a meter, and you know, that's what I'm going to do for Alan. The problem is, if I just put power it up, you'll see it's now working. There's receive, needs aligning. This meter's open circuit. It's not the actual needle that's stuck like they usually are. The actual thing's open circuit. So the way this mounts, you've got this bracket somehow you've got this bracket. How does this work? Am I losing the plot? Yes, well, we'll see if we can get that to fit in. Most meters are deeper than these, and then they catch on the switches. The only meter we got was that one. I'll put that back on there for something it does fit. Hopefully that will just go round. It looks like it will. Meter lamp it goes through a little slot here in a rubber holder, and it's the opposite way on. It went in through the right on this one, goes through on the left. So I just pulled the wires around a bit so that it goes through on the left, but it's exactly the same arrangement. There we go. And hopefully screw the set back together. Right, we'll just power it up and make sure things look like they're working. Right, so we've got S9 on the signal generator, so 100 microvolts. So we need to adjust the needle for S9. So which preset, RF meter, a signal meter, and my power's gone off. It's the trouble when you're not using a proper power lead. Not sure where Alan's got these capacitors from, but that looks like it's about to vent. You know what? It's not sat in the window properly. Back to the drawing board. Right, so I got to the bottom of what the snag is. You have to put these meters in the opposite way round. So the Uniden meters, the wiring's to the top. I said the meter thing was to the lamp was to the right, and on this one, the meter's the opposite way on. So you've got to put the meter bulge to the other way in, and it won't go because of those switches. So what I've done, I wouldn't do this for anybody else, but what I've done is to actually borrow this out of one of our own identical sets off the shelf, which is ready to be serviced. So it now isn't ready to be serviced because the meter's missing. So there we go. So we'll pop that back out, and we can put that back for our Fidelity 1000. So we've no longer borrowed that. Put that back with that. We've got to hope this works. Right, so without the meter lamp, well, I'll tell you what, we may as well put the meter lamp in. So I'll put the wiring back the other way round. Right, well, now what happens? I expect our power lead to come off. Of course it has. So that works. Power back off and fit it back in to position. So how does this work? It goes round there. So I will have spent longer on doing the meter than the rest of the set, and that is absolutely usual. Once again, try and put this back together and still have a working set. And calibrate the meter, so signal meter for 9, and on transmit we've got 4 watts coming out, so it wants to be centre of the red zone, so just a little high. So I've got to hold the radio and key up. That's minimum. Well, that's minimum, so it's a little bit high. Good. So that's not come out of a scrapper, that's come out of a stock set, so I wouldn't do that for anybody else. Now means we've got to buy another set to cannibalise for the meter. Need to change that capacitor. I don't know why that is like that, but it's going to pop its clogs. So that is now 4.5, which is a little bit high. That's correct, it's 100 microvolts, and everything else is right. So do this capacitor. I just can't see what's happened because it's as if it's been overvolted. $374, should be 470. It ain't right. Don't know what's happened to it, but it's going to have to be changed. But the thing is, it's domed where it's got the serrated top, so that it can vent. It's like activated as if it's been hot. So he's got. I mean, there's no reason why he can't put 25 volt rating in. I'm going to be upping the temperature to. Oh, it is. He's put 105 in, but anyway, there you go. It's one of those things, isn't it? Okay, so we're all done. So I've put the bottom lid on. Time to put the top lid on, and fingers crossed that this speaker works. I think we'll find out the polarity, although it doesn't matter. I'll still find out the polarity because with them being two grey wires. Well, that's not negative. That one is negative. The one in my paw is negative. So although the tune-up won't make a huge difference to performance, it's nevertheless balanced properly now, drawing less current, so the PA is working less hard, and the squelch actually works right. Excellent. I know these want screws in the back, but I just want to get the on the air test out of the way, so we'll just put 4 screws in instead of 6. Right, signal generator off, test equipment off, squelch on. Oh, check this speaker. Yeah. And we'll plug the aerial in instead of the test gear. So usual Antron 99 or whatever it is, Solarcon 99, Cadbury's 99 something. Not blown down in the wind. One Anna Roger. Good. There we go. One Uniden Uniace 100. Back in the land of the living. What I haven't done is his mic. I really want to have that working for the on the air test, don't I? I just hope he hasn't got a duff insert. That's audio hot. Yeah. Right. Now I'll have to fix his mic behind the scenes. The microphone insert's open circuit. So the fact that has happened, it's not going to be like the original mic anyway, is it, when I replace it? So we'll do it all on the test mic. So I'll do that behind the scenes and get him a working mic, but it'll be a different insert. So there we go. Thanks for watching the Uniden Uniace 100 from 1981, specially sorted out for our mystery benefactor Alan, but this is actually a repair for him.